Hi, my name is Abhishek, and as a part of my digital forensics course, my final project topic is malware detection through behavior-based indicator of compromise using volatility. So, the current approach in detecting malware is by the use of malware-specific signatures. This signature make use of hashes of files on the system and then do a comparison to the infected hashes of the files, and uh, the method in which the signatures are used is not very suitable for malware detection, as it does not take into consideration zero-day targeted attacks and polymorphic or self-mutating malwares. But most modern malware make use of these techniques and other evasive techniques to hide themselves from being detected. So the proposed approach is by use of behavior-based malware. So in this project, I'm going to use the indicator of compromise which are based on behavior of the malware, like file accesses, process injection, hooking, mutex modification, and other things. So these would be focusing on attributes and behaviors of malware, which would help in detecting them on an infected disk. This behavior of malware can be extracted by the use of static and dynamic analysis. So basically the goal of this project is to find an efficient way to document the dynamic behavior of the malware, which could be exchanged between the other researchers and also could be parsed using a tool. Also, this behavior-based indicator of compromise uh, should be documented in such a way that it could be extracted from the infected disk by using some other tool and could be compared and come to a conclusion that the given image is compromised or not. Uh, for documenting the behavior of the malware, I'm going to use MIC, which is Malware Attribute Enumeration and Characterization. It is open source project by MIC Corporation. So it has a readily available Python binding which could be used to generate the XML document which could be used to define the malware dynamic behavior. Mic operates in three-level actions. For example, the file accessed and opened by the malware; behavior, that is the registry it would create to while it is on the system; and capability, which for example is the persistent mechanism the malware may use to be on the system. For extracting the indicator of compromise from an infected disk, I'll be using Volatility Framework, which is an essential tool for digital forensics. It is very cross-platform, can be used on different operating system and different architectures, and also it is extendable by use of plugins. So the sample malware I'll be considering for this project is ZeusBot. Uh, it is a variant of ZeusBot which has a evasive behavior and a very low detection ratio because of high number of variants. Also, it was recently detected in October 2016, and it is compatible on Windows 7, 32, and 64 architecture. Uh, so I'll be choosing this malware for our test because of its high volume of actions and behavior which could be documented using the mic format. So the first method step in the project is image acquisition, which is acquiring the infected disk. For this, I infected a virtual box, sandboxed virtual box with ZBot uh, malware, and then extracted the for RAM analysis. Uh, Post that, using the Mac Python binding, I wrote a program to define the behavior of the malware based on this indicator of compromises and exported it to a XML document. And then I used the volatility plugins to detect different IOCs from the infected disk. So the pros of the project is that it does not rely on signatures for malware detection, and due to the more malware specific indicator of compromise, there are less number of false positives. And due to the reliance on the volatility plugins, it is very easy to port it on different operating system and architecture, all which are supported by the volatility. So one downside of this approach is that the malware is to be analyzed before, and all the indicator of compromise are extracted before it is and defined to be run and documented in mic format. So one of the future ways the project could be extended is by uh, integrating various different injection detection techniques into the tool. Also, a different approach could be taken to define more general behavior of malwares, but this would lead to more false positives. So now for the demo, I'll be running the uh, generate Mac document Python to generate a XML folder, which would look like a XML document like this, with all the defined behavior of the malware. Once that is done, uh, we could run a malware scanner, which could extract all the uh, different IOCs from the infected disk image. So the it has been extracting processes which are malicious, which are declared in the malware behavior. It will extract the other hidden processes and images and files which are associated, all the DLLs associated with the malicious processes, and then it will extract all the mutexes which are associated and opened and accessed by the malicious process. It will detect all the code injections too, uh, which were performed in the infected disk and defined in the XML document. Also, the persistent mechanism is declared in the file, so this will try to get in, then read the registry accessed by the malicious process and check to see if it is persisting or creating any registry which would allow it to run every time the computer is booted up. It will detect for API hooks. This process takes a long time to detect the API hook in the infected image, but it detects all the processes which uh, have potentially hooking mechanism using the volatility plugin. And once it has detected hooking process, as you can see, it takes 20 minutes, and it dumps the processes and uploads it to the virus total to confirm if uh, it is malicious. As you can see, the process is uploaded to virus total and two AVs detect it as malicious. Once it has completed, it dumps a report file which looks like this, which has all the information of the code injection, malicious process, mutexes, and dump processes, also API hooks and persistent mechanism. Uh, this report is pushed in the same folder. So as you can see that the program is able to detect all the indicators of compromise defined in the mic document and positively flag the image as infected. The indicator of compromises include all the hidden processes, files, mutex which are present in the report. Also, it detects the code injection and persistent mechanism in the malware. More detail is provided in the report attached with the project. Thank you.